4, 3, 2, 1, 0.
Hello everyone. Welcome back to a new video of Team Scientify. Hope you are doing well. Today's topic is alternating series and Leibniz's test of convergence.
First, we will define alternating series. So, an infinite series whose terms are alternately positive and negative is known as alternating series. So let's say a series is given as u1 minus u2 plus u3 minus u4, and this continues, where un is greater than 0 for all n belongs to natural numbers. So this is an alternating series, and this can be denoted by summation of minus 1 to the power n minus 1 un. Now let's take a look at an example. Now for example, 1 minus 1 by root 2 plus 1 by root 3 minus 1 by root 4. This series is an alternating series as it is positive and negative alternately. Also, 2 minus 3 by 2 plus 4 by 3 minus 5 by 4. This series is also an alternating series. So how do we test the convergence of an alternating series? We use Leibnitz test. This is a test for convergence. Let's look at the conditions. So, an alternating series is said to be convergent if number 1, each term is numerically less than the preceding term, and the second condition is limit n tends to infinity, un must be equal to 0. So let's test the convergence for this series, which is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5, and this continues. So the given infinite series is this one, and this is an alternating series. Also, 1 is greater than half, it's greater than 1 by 3, greater than 1 by 4, greater than 1 by 5. And also, we see that un equals to 1 by n. Therefore, limit n tends to infinity, un equals to limit n tends to infinity 1 by n, which equals to 0. Hence, by Leibnitz test, the given infinite series which is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5. This series is convergent as it satisfies the given conditions. For our second example, we take the series 1 by x minus 1 by x plus a plus 1 by x plus 2a minus 1 by x plus 3a. Okay. This series is an alternating series as it is positive and negative alternately. So our first condition is satisfied. Now to check Leibnitz test, our first condition is the terms are continually decreasing and x is less than x plus a less than x plus 2a less than. This continues. The second condition is limit n tends to infinity un equals to limit n tends to infinity 1 by x plus n minus 1 a, which gives us limit n tends to infinity 1 by infinity. So this is equals to 0. Now since all the conditions are satisfied, so we can say that the given series is convergent. And our third example is, we will check the convergence of the series summation n equals to 1 to infinity whole of 1 by n plus minus 1 to the power n plus 1 by root n. Now we already know that summation of un plus vn can be written as the summation of un plus the summation of vn. So the given series can be written as summation n equals to 1 to infinity 1 by n plus minus 1 to the power n plus 1 by root n equals to summation n equal to 1 to infinity 1 by n plus summation n equals to 1 to infinity minus 1 to the power n plus 1 by root n. So the second series that we get is a convergent series, and we can prove this by Leibnitz test. And hence its sum is a finite quantity. But for our first series, which is summation 1 by n, it is a series of positive terms of the form summation 1 by n power p, where p equals to 1. So we will apply our p test. So what is the p test? The p test is also known as p series. This is when summation n equals to 1 to infinity 1 by n to the power p. This series is given. This given series is convergent when p is greater than 1 and divergent when p is less or equal to 1. So from here we can proceed with our sum. So by the p test, it is a divergent series. this summation 1 by n is a divergent series, and hence its sum is infinite. So the sum of the given series is also infinite, and hence the given series is divergent. And so in this way we test the convergence of an alternating series.
This is all about today's topic. Thanks for watching. Hope you like the video.